Hello and welcome to the Daily Space for today, February 22nd, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. It has been a wild 24 hours for space science. I saw many aerospace journalist this morning basically going, "Oh my God, make it stop." And this is because it has been non-stop spacecraft for 24 hours. And we are here to bring you a quick roundup of what we know about what has been going on. The first thing that occurred yesterday was a little robot, roughly the size of a tiny car, decided it was going to make a close approach and reach out and grab a little bit of the surface of an asteroid it had just shot with a space gun. This, of course, is the Hayabusa 2 mission that is led out of the Japanese space agency JAXA, working in collaboration with ESA and a little bit of NASA. Now, this little robot that has been orbiting and mapping this nearby asteroid for several months. It originally planned to go in and do a grab and go back in October, but it turns out this rock isn't anything like what they expected. The surface of Ryugu, the asteroid that Hayabusa 2 is orbiting, is much more bouldered, much more topographically diverse than they had ever imagined. So trying to find a place on the surface where it was safe to take in their spacecraft was a greater challenge than expected and required a lot more practice and doing of dress rehearsals than expected. The goal of this mission is to actually go in and grab samples from 3 different places on the surface of Ryugu to then leave the orbit of this nearby asteroid and fly back home to Earth. The departure is slated for December of 2019. The arrival is slated for December 2020. And we're all eager for those samples, but Hayabusa 1, the precursor, didn't work so well. It had a problem where after gathering its first sample, it wasn't able to lift back off the way that it intended, and the overheating of the engines just meant that the mission couldn't complete all of its science. So they were cautious. They tested things out. They tried things out. They made sure they could do what they needed to do, which meant taking their small car-sized spacecraft and touching down within a 6-meter box, grabbing a sample, and taking back off. We now have back the first images of this successful attempt. So what happened was Ryugu went in, flew over the surface, captured specific telemetry off of a target marker. Once it confirmed its exact location over the surface, it then came in, tilted sideways, landed on a sloped bit of surface on Ryugu, fired a propellant shot, essentially fired a bullet, into the surface of the asteroid after lowering a horn over that part of the asteroid. This meant that all of the debris splashed up by that bullet impact would then be gathered up inside the horn. We now know that the command executed, the bullet fired, the horn gathered a sample. We don't have details yet. All we've got is this image, but it's kind of awesome. Now, in looking at the image, everyone is still trying to figure out everything that's going on. So here's what we know. First of all, this is the bouldered surface. You can see just how many different hazards the spacecraft had to avoid. This darkened area on the surface, that is that's the area that got darkened by the engines on Ryugu lifting the spacecraft back up. And the question that we're all waiting to hear the answer to is, are these dark smudges that we're now seeing, are those flakes of dust that are on the camera? We don't know yet. But here, of course, is the shadow of the spacecraft. So It was an excellent mission, and we're all now waiting to find out when will it go in and make its second and third sampling attempt as it prepares to bring back asteroid debris to the planet Earth. This won't be the first time for Japan doing this. They also brought back a sample from Itokawa, and it's just all kind of awesome. So, okay, in other news, a few hours after all of the Hayabusa 2 excitement had come to a close, we had the launch of SpaceX carrying, among many other things, the Bereshit lander for the SpaceIL team. SpaceIL is a team that was put together to compete in the Google Lunar X Prize. For a variety of reasons, none of the teams competing in the X Prize competition were able to get to the moon before the competition came to the close. This, in part, was due to significant delays in construction of the rockets they needed to get to the moon. It's all well and grand to have a lander, but unless you have something to fly you there, you're not getting there. Well, SpaceIL is the first of these teams, many of which are still striving to get to the moon, still striving to show what they're capable of. It was the first mission to take off. And it's currently in orbit around the Earth. Once it does system checkouts, it's going to work on changing its orbit slowly but surely, making it more and more elliptical until eventually it's able to fire its engines and go from orbiting the Earth to instead orbiting the moon. This slow and gradual raising of orbits is done to conserve energy. This is a little tiny lander. Again, much smaller than a car. And it doesn't have a whole lot of propellant on board. So slow and steady is the way to go. Now, once this little lander gets itself over to the surface of the moon, it is going to execute the original plan from Google Lunar X Prize, which was land on the surface of the moon, and then, by whatever means you choose, move 500 meters across the surface. You can flit, fly, dig, dance, whatever you want to do. Hop. Hop is what this particular lander wants to do. Move yourself 500 meters across the surface and then send back high-definition video. We're not exactly sure what timeline this is going to happen on, but as we learn more, we will bring it to you right here on the Daily Space. So the first step has been taken. Now, some of you may have seen some interesting news reports coming out today stating that NASA had placed instruments on the first commercially selected moon landers. And what is left off of a lot of those news reports is the word U.S. This is the first commercial lander going to the moon. And yes, it is carrying a science payload. It's carrying a magnetometer. Yes, it was made by NASA. But all those press releases this morning talking about future commercial landers. No, this is that first commercial lander. And let's celebrate what is being done. We currently see Japan having bypassed the moon completely, reaching out and visiting asteroid after asteroid with plans to carry it all the way to the moons of Mars and back again. We are seeing Israel becoming the fourth nation to land on the moon, hopefully if all goes well, following in the footsteps of the US, USSR, later Russia, and China. So it's a global exploration of a universe we all share. Now, not to be outdone, commercial space just keeps on trucking along. And this morning, because the news just can't stop and give us a break, Virgin Galactic took out for a ride White Knight 2, and with it, they carried Spaceship 2, and they did their second launch test. In this case, they carried up with them a series of a pilot, a commander, and actually their astronaut trainer. So on board this mission, we had Dave Mackey, chief pilot of Virgin Galactic, Mike Such Masucci, who was the pilot. And then additionally, there was Beth Moses, who is their astronaut trainer. Now, there is some debate over whether or not you can say that these folks made it into outer space. They made it up pretty far. They traveled up 55.87 miles. This is 295,000 feet, 89.9 kilometers. They crossed the line, which Virgin Galactic considers the line to get into outer space, but 100 kilometers, just 11 kilometers more, is the more generally accepted boundary to outer space. So I leave it to you to decide whether or not you consider this the next 3 people to have made it into space. This is nonetheless, we're seeing commercial flight taking place in a myriad of different ways. We are getting ready for space tourism to begin to become a thing with all of these different test flights, landings, processes. And coming up in the coming days, because it just can't stop. In the middle of the night on March 2nd, we are going to have a SpaceX launch testing their crewed Dragon capsule. It won't have humans on board. This is a test flight. It will be taking it all the way up to the International Space Station and returning it back down. Now, there are some news reports showing that there are concerns about this. Undisclosed, or rather unidentified national officials and various leaked documents are expressing concern that the parachute system and the basic return to Earth systems don't check out quite as well as people would like. It's a good thing that this is an unmanned, unwomaned, unhumaned, uncrewed is just hard to say, launch. Because these are new technologies. I know everyone is so very eager to get human beings returning to space on, non-Russian spacecraft. Non-Chinese spacecraft. Both those countries have spacecraft launching humans. But let's run some solid testing before we have SpaceX carrying people. We'll get there. And when we get to that March 2nd launch, if it stays go to go, we will be bringing it to you right here on CosmoQuest. It's unclear if Annie or I is going to, take that one in the middle of the night, but one of us will have your back, and we will be bringing you a chance to share the experience on CosmoQuest. And that pretty much concludes my news for today. And now I am here to answer all of your questions. While you're typing those in, please remember to type at CosmoQuestX to help me find your questions in the chat. And while you're typing them in, I just want to remind you, this is a product of CosmoQuest. We are your place to learn and do science. And this channel brings you more than just the daily space. Yes, the daily space is here for you most Monday through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, 6 p.m. London time. We also bring you, as we did yesterday, launches, landings, and special events involving our space exploration. We are also going to start bringing you, a view into the coding we do and how we are preparing to come back in full force as a place for you to help us explore the universe we all share. We are here thanks to the generous donations of people like you. This is where you can insert your NPR sponsorship message, where I remind you, if you like what you see, take a moment to consider giving. Look at how much you have spent on today's cup of coffee. I used a Keurig, and that meant I'm giving to this channel because, this channel pays Annie's salary, and I figure it's worth giving the amount of a cup of coffee to be able to pay her salary, to be here doing like she did last night and covering the amazing launches that are going on. We are here thanks to you. We are sustained through your subscriptions. Every bit really matters. Please consider giving so that we can make the world more scientific. And we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are part of a 501c3 nonprofit dedicated to exploring our solar system. This means that when you give, it's tax deductible wherever the law allows. So, okay, that's it. That's enough begging for today. Let me get to your questions. Okay. Yeah, Annie did great last night. Annie is absolutely fabulous. And her dogs, oh my gosh, I need to figure out how to replicate her setup, because she has her dogs staring into the camera, begging for you to give bits so that it will rain Cheerios. It is amazing. So yeah, Annie is awesome. Okay, scrolling back to see what questions I can find in the chat. Scrolling all the way back. Okay, I found the beginning. Malted meteors? That should be a new candy. I would buy that candy. I would totally buy malted meteors if it were a candy, as long as it's like chocolate and malt and just shaped in a gnarly shape. Okay, let's see. Not a lot of questions today. Ruff's Matt is saying Spaceship One did 3 flights above the Kerman line, 100 kilometers. CosmoQuest X, I think that the bar set by Virgin Galactic before, they should be trying to best that when they can. So Spaceship One was a spaceship that was done by Scaled Composites, and Scaled Composites got purchased by Virgin Galactic. And this is where you have Richard Branson has a lower line than Burt Rutan, who's the 100-kilometer line. Burt Rutan and Spaceship One won the Ansari X Prize competition to show that you can have one spacecraft go to space, come back down multiple times in a short period of time. And part of the competition was to set that line at 100 kilometers. Well, Spaceship Two with Virgin Galactic no longer is working with Burt Rutan. He's retired. And Richard Branson, as he strives to move his company forward after many setbacks, well, the line, in this case, the bar, has literally been lowered by a number of kilometers. So Larry Weird and Proud is asking, does Virgin Galactic have plans beyond joyrides? Yes. While their primary configuration for their spacecraft is to have seats for, well, tourists, they also plan to be able to launch racks of experiments and potentially even teachers and students that are carrying microgravity experiments. So just like your standard commercial airplane has multiple configurations, sometimes they put the bathrooms here, sometimes they put the food cart there. Well, this spacecraft will also have multiple configurations. So stay tuned as we figure out how to pay to get student experiments into space. So DPI 209 asks, will they at least have a crash test dummy on board? I assume that you're talking about the SpaceX launch of their human usable capsule. And this is the great question mark. In the past, SpaceX has done awesome things. And by awesome, I mean totally giggle-worthy, but not very scientific. They have in the past launched things like a wheel of cheese. And so I'm sure there will be some sort of creativity involved. They are going to the ISS, though, so we'll see what they're taking to the astronauts. Now, I do expect that there will be things like spacesuits that are being used to test both the spacesuits and the capsules, lots of sensors, lots of measurements taking place. But I'm really hoping for a wee bit of silliness as well, a wee bit of silliness. So Stormer Joe asks, how big is the sample they took? So we don't have an exact measurement of how big Hayabusa 2's sample of Ryugu is. Their original intention was to get something that was between 1/10 of a gram and 10 grams. And the largest sample the horn was able to collect would have been 1 square centimeter, so about 1/2 inch across. We don't know yet how big it is. They just haven't released that information. But expect somewhere between not a lot and the weight of a penny or so. So it's tiny. It's tiny. Mythtown, Annie does indeed sleep. She has stayed in my house. I know she sleeps. She just doesn't always sleep normal times of day, but neither do I. So we'll sort. Henny Thorverb asks, how will the Ryugu mission be coming back to Earth? Will it be like a Soyuz? So in this case, Hayabusa 2 is a ion-powered spacecraft. This means that it uses a combination of electric and magnetic fields to charge particles and shoot them out the back end of the spacecraft at extraordinarily high velocities. This doesn't produce a lot of change in velocity that is extraordinarily fast. This isn't a 0 to 60 in 5 seconds kind of spacecraft. This is a lot slower of an acceleration, but it is also the most energy efficient form of acceleration a spacecraft can have. So they will be firing their ion engines and doing a slow and steady orbital transfer from the orbit of Ryugu to match the orbit of the Earth. Once they get to Earth, they will be jettisoning their storage capsule. It will be coming down through the atmosphere, dropping its heat shield, deploying parachutes, and coming down, we believe, into the outback of Australia, because Australia is a big empty place where you can drop things. US has done this on accident with our Skylab satellite, or rather space station. This time we're going to be purposefully dropping things on Australia, or at least Japan is going to be purposefully dropping things on Australia. They will be scooping up that sample, taking it to Japan, where they have an amazingly sterilized, tightly controlled environment where they can make sure that there are no contaminants exposed to that sample. They are going to start by measuring all of the volatiles in the storage container and then removing the solid samples for processing. There's actually going to be defined ways that scientists from around the world can request small bits of these samples to process for themselves. Let's see what else. I don't think, Trekker Kev, that there is a way that dogs can have too many Cheerios. No such thing as too many Cheerios for a doggo. So Biska is saying, I always forget to @ CosmoQuest X for my questions. I'm sorry. Yeah, the chat is so busy. I just need you to do that. Thank you for trying again. Do you know what the difference between the Ryugu mission and the OSIRIS-REx approach for sample grabs? I don't know the details. I have to admit, I am working with the OSIRIS-REx mission. We're working on the software that they'll be using for site selection, but I've been so focused on the software side of things that I haven't looked in detail to see what the differences are. I know that both missions are using a touch and go approach where they are coming in, grabbing a sample, kind of like one of those claw things that you can stick a coin in and try and grab a stuffed animal. They're both coming in and doing a grab and go. But other than that, I don't know the fine-grained differences between the missions. The two asteroids they're at, while looking very, very similar, have different compositions, and they're two very complementary missions. So stay tuned. I will have more details for you about OSIRIS-REx as we go. So let's see. Astro B, who also did not remember to @ me, but just happened to be underneath a very cute rabbit, asks, will Virgin Galactic be cheaper than Blue Origins to go to space? I'm not sure. Last I saw, Tickets on Virgin Galactic were something like $250,000. I don't know what the price is now. Thank you, Trekker Kev, for the subscription. Thank you so much. This makes it, wow, it says that this is your first month. Thank you. You guys have been a tremendous support in so many ways. Okay, going back to answering questions, and let's light up the chat for that. I just don't know the prices anymore. The prices have been highly variable, and where tourist launches. Thank you, Mythtown, for the subscription. Let's keep lighting up the chat. Thank you so much, Mythtown. So I don't know, bottom line. Once we get to the point that people are actually like able to select their seats, then I'll start worrying about prices. Okay, so Hanny is asking, will Blue Origin be making ships that can go to asteroids ultimately? I don't know. Plans change. I tend to not pay attention to spaceships until they're like on the launch pad. Or are they going to do commercial flights in addition to the overview effect flights? Blue Origin actually is going to be doing a whole lot of different stuff. They are one of the groups that is also trying to figure out how to do contract work for NASA. Ruff's Matt is saying, thanks for your good info about Virgin Galactic altitude. The other side of the coin is speed. Is Virgin Galactic planning to go faster than scaled composites or not quite so fast? I don't know those details. Ultimately, they're going to need to go faster, I think, because they are planning to break that 100-kilometer height, but they're not there yet. Hopefully they bring groceries. I assume that you're referring to the March 2nd SpaceX launch of a non-occupied human-capable capsule. Yes, they're inevitably bringing something to the ISS. They could toss Cheerios at the astronauts, only if the astronauts donate to CosmoQuest. That's how you get Cheerios thrown at you. The moon is not made of cheese, but oh my gosh, that would be amazing if it was. So let's see. Astro B asks, will Virgin Galactic be cheap? Oh, that one I found up above. Okay. So Fennec Fox, that's what that is. So thank you, Mythtown, for that being 2 months. Thank you so much. Oh, and Larry, you need to buy that domain now. Who knows how that will pay for your future. So yeah, thank you all so much for being here. That seems to conclude our questions and conclude this episode. We will be back on Monday bringing you all that is new in space and astronomy. I do have some like boring drudge coding that is actually kind of pretty though. And so I may or may not be streaming that. I have to finish writing a research paper before I'm allowed to do anything else. This is what I have to do to myself to finish writing research papers. I love writing. I hate writing research papers. So I may or may not be on doing some coding at some point randomly between now and Monday. Stay tuned. We will be back. Thank you, Fenring, for the cheer. Thank you so much for the bits. Yes, you should be an astronaut, and I should be throwing Cheerios at you. Hey, Batsky Starman, I'm so glad that Bill did that. Can I get a shout out for Bill Nash in the chat? Bill is another educational streamer here on Twitch. He streams photography work, and he does some astrophotography as well as a whole lot of city, sidewalk, human photography. It's really beautiful to just watch his stream. It's an eye candy stream. Those happen and they are fabulous. So I'm now trying to figure out where on my screen I hid Discord, because I am going to find someone to raid. And for me, raiding always comes from whoever is now live as part of the Knowledge Fellowship. The Knowledge Fellowship is a Discord filled with educational streamers. So looking to see who all is there. So EJSA is currently streaming from the Intrepid Kids Week 2019 flight deck. So I will be raiding over to him when this show is over. So thank you all for being here. Thank you for joining me. And thank you for taking an interest in science. In order to keep track of whenever we go live with the Daily Space, as well as all our other randomness, give us a follow. Our next episode is actually going to be, for certain, if I don't pop on earlier, on Sunday with Annie Wilson, who will be bringing you her Sunday Science Hour at 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific time. So thanks for being here. Thank you for all your interest in science. Thank you for being you. And once again, we are supported by the generous donations of people like you. Thank you so much for making, this job possible and for paying Annie's payroll. So thank you. And wherever you are in the world, have a fabulous morning, evening, afternoon, and if the weather allows, get outside and look up. Bye-bye.